On your whiteboard, please tell me, Jane Goodall is a perfect example of what type of research? Jane Goodall is a perfect example of what type of research? Good. Annalise. Naturalistic. On your whiteboard, please tell me, what is the name, what is it called when a person doing naturalistic observation has negative connotations about something, and that affects their ability to evaluate without judgment? Good. What is it, Miss Curtis? Observer bias. On your whiteboard, please tell me, what is it called when people who are being observed in a naturalistic setting feel genuinely uncomfortable and then change their behavior? Good. What is it, Hayden?
Observer effect.
Observer effect. On your whiteboard, please tell me, what is the name of, what is it called when I put limitations on what something is? So, if I'm going to do an experiment on goldfish, I have to be very specific of what qualifies as a goldfish and what does not qualify as a goldfish. I got 1, 2, 3, 4, 5. What do we got? Luke?
Operational definition.
Operational definition. On your whiteboard, please show me what a positive correlation looks like. No, you're missing 2 lines. What does it look like, Sydney?
A straight line going up.
Thanks, Sydney. Positive correlation has an XY axis and it goes up. It means if one goes up, the other one goes up. The more I study, the better I do. On your whiteboard, please tell me what a no correlation looks like. Good. A no correlation looks like that. Means my height dictates my favorite food. They have no correlation. They are not related. Okay. I want to talk about correlational coefficients. Have out your notes ready to go. We know that a negative correlation, a perfect one is -1. A positive correlation has a score of +1, correct? And a no correlation has a 0. So if it is 0.98, it is a, if it is -0.98, it is negative. The closer it is to the positive and the negative, the stronger it is. Everyone clear on that? Good, because you have a question on that tomorrow. I want to make sure everyone's clear on that. Okay. Let's start with this little sheet. Okay. Let's start with this sheet. We'll start with the little dudes on this side. You need to know. Oh, sorry. Oh, you didn't get to see what I was just doing. I drew everything out. Sorry. Okay. So we need to talk about mean, median, and mode because you are going to, now please listen very carefully. Tomorrow on your test, if you're uncomfortable with math, anyone here uncomfortable with math? I'm going to put 2 hands up because I suck at it. If you are uncomfortable with math, you are more than welcome to bring a calculator tomorrow because you will have to find out either the mean, median, mode of some basic numbers. You can do it without a calculator, apparently.
Yeah.
I am not one of those people, but apparently if you have enough fingers, you can count that high. So, if you would like to bring a calculator for class tomorrow, you're more than welcome to. I'm not going to let you use your cell phones because I think we figured out why, right? So, no cell phones, but if you'd like to bring a calculator for class tomorrow, and you are more than welcome to use it for sure, okay? Today, you are more than welcome to use your calculator. We'll be using it here in a few minutes. So, I just want to go over basic statistics here. Mean means what? The middle score. How do you find the middle score, ladies and gentlemen?
Isn't the middle median?
Sorry. See, this is why I don't teach math. This is your average score. How do you find your average score?
All up.
You add up, and then you divide by the total. Okay? So, tomorrow, if you have to find the mean, ignoring this part, whoopsie, you can find the average. Everyone's okay on mean. You should be comfortable with this, despite the fact that I'm ruining it. Okay. Mode is going to be the most occurring. Okay. So if number 5 is used 3 times, guess what the most occurring number is? 5. Everyone okay on mode? And then median is the middle score. I'm so passionate about it. I try to make it everything. It's the middle score. How do you find your median, ladies and gentlemen? Caroline. There you go. So you start crossing off. You can do it the old school way. There you go. So you can cross them off until you get there. Everyone know how to do that? Yes, you have to line them up. Yeah, you can't just like randomly start crossing things off. Okay, everyone feel okay? There's one question on one of these 3. It has a nice simple data amount that you can do the basic math without the calculator. But if you feel most comfortable with the calculator, please feel free to bring it. Everyone okay on this side? Perfect. Okay. This is standard deviation. Standard deviation is tricky. Standard deviation is a very big deal, but I'm going to simplify it for you. Is that okay with you? Okay, standard deviation looks like this. This is what we call a bell curve. This deals with averages. Okay, it deals with averages. Okay, so this center line right here, this center line is called your mean. So if it's your mean, it's your exact what? Average. Okay, so it is your exact average. From this line to this line is called one standard deviation. From this line, from your median down, is also called one standard deviation. So when we're talking about one standard deviation, depending on what side it's on, you say one standard deviation above the mean or below the mean. Everyone understands the language we're using so far. Now, in a bell curve, one standard deviation above the mean holds 34% of the data. One standard deviation below the mean holds 34% of the data. So, who can tell me what is the percentage of data held within one standard deviation of the mean? Hayden. 68%. Does everyone understand how we got to 68? One standard deviation below to one standard deviation above, 68% of all the data is right there. So, most people are located right along the mean. Some of us are smarter, some of us are dumber, but we are right along the mean, 68% of the population. Okay? Going 2 standard deviations, that's what this is. This is 2 standard deviations. This is 2 standard deviations. Okay? 2 standard deviations above the mean is 13.5%, 13.5%. Okay? Then we go to 3 standard deviations below the mean, which is 2%. And going above 3 standard deviations above the mean holds 2% of the data. Above in your fourth standard deviation above the mean, you have 0.5% of the data. Below 4 standard deviations, you have 0.5% of the data. Now, ladies and gentlemen, this shows us that 68% of the population are what? Average. As we get further from average, we have less and less people. If we're dealing with normal average intelligence, 68% of the population are right around average. There are some people who are above average. Some people are exceptional. Some people are geniuses. Now, if you look at Plan High School, we have plenty of people who are under the gifted guys, which falls under 2 standard deviations, and 35% of our population here at Plant apparently is labeled gifted. What do we say about that? Looking at how it's impossible. It's not. It can't be done. We don't have something in the water here that makes us smarter than the average people. And if you're one of those gifted people, I'm not like shitting on you. Like, it's just facts. This is a bell curve. This is how your AP scores are given out. This is how all of your college exams will be given out. There are only one person for the SAT. This is a perfect example. So this is how your SAT is scored, ladies and gentlemen. They only allow 0.5% of all people who take the SAT worldwide get a perfect score. They only allow 2% to get in the very top tier. They only allow 13.5% of the population to take it, get in the second top tier. They allow 68% to get around a normal score. Okay? So, this is how things are distributed in all of your standardized life. Your AFCATs, done. Your FSA, this is how it's done. They allow only certain amount of people per each thing. What do you got?
What do you mean, like, allow?
They literally change the scoring so only 0.5% get it. Because they throw some test questions out, and they throw some out that everyone got or no one got. And that way it kind of skews the data, so it sets it up to a perfect bell curve. There's some kid who didn't even get points for putting his name on the SAT. That's what this tells you. So don't be that kid. Maybe you took a great nap, though, so you never know. Okay? So, is everyone, all of this shows 100% of the data. Is this, everyone's clear on this? So this is below, and this is above. Okay, everyone's comfortable with this. Now, here we go. We have to figure out how to find standard deviation. Okay, so here is my raw data. Okay, so I have 160, 150, 139, 102, 102, 100, 100, 100, 98. 95. That's my raw data. Now, just to make sure everyone is okay, can we... That's an 8, yeah. Don't judge it, okay? What is the mean, median, and mode? By the way, I put them in order for you, so to make it a little easier for you. What is the mean, the median, and the mode for this data set? I put them in numerical order for you, so I just made it a little easier for you.
No, it's fine.
What? All right, who can tell me what is the mean? Take out your calculators. That's why you have your phone on your desk here, people. What is the mean of this data set? Yeah, are you sitting there trying to do this off the top of your head? What the hell are you doing? Take out your damn phones. That's why you have them on your desk. What is the point? You can do a calculator or your phone. I don't care.
116.
116 point...
Oh, no.
No, it's wrong. It is. It's 114.6. 114.6 is your mean. What is my median, Kelly? 101. Okay? How did you get 101, Kelly?
Since there's 10 numbers, I added 102 and 100 and then divided by 2.
There you go. And what is the mode? 100. Does everyone understand how we got that? That's good practice for tomorrow. Everyone's okay? Yes? Perfect. Okay. So we have our raw data and we're trying to find our standard deviation. Okay? So we know that the mean is 114.6. Okay? So what we have to do, now that we have our mean, we have to figure out how far these numbers are from 114.6. This is called the deviation from the mean. So what you're going to do is subtract 114 from 160. And that answer is 45.4. So in this column, you're going to write 45.4. Then you're going to subtract 114.6 from 150, which happens to be 35.4. And you guys are going to do the rest, by the way. So figure out what my deviation from the mean is. So everyone should be on their little calculator doing a little math here. So you're just taking whatever the raw score is and subtracting 114.6 from it and coming up with the deviation score. Of course, when you get to 102, ladies and gentlemen, it's negative 12.6, which makes sense because it's on the below the average, right? Which we just talked about. Okay, so check your numbers. Those are your totals. Okay, then we're going to do the square. Square the deviation. So what we're going to do, so we have 45.4, and we're going to square it. So the total comes out to 2,061.16. You're going to square it. Sophia, are you okay? You were not expecting to doing big math in AP Psych today? So whatever it is, so 35.4, you're now going to square it and write down whatever that number is. Oh, on the iPhones, they have a nice little button for it. Nice. So you're going all the way down.
Wait, so what do we? Oh, we have to do it with all.
Yep, you got to do them with all.
So the IQR.
I'm sorry, what?
The IQR of the interquartile range.
What the hell are you talking about?
You took the raw score and then like put it with the IQR, like you would get each substitution.
I don't know what you're talking about. I'm so sorry. This is how I know how to do it. This is how I know how to do it, so this is what I'm doing. Yeah, it's kind of nice, right? How's it going over there, Camden? You look like you're really working hard.
Always.
Mm-hmm. If I'm sitting here doing math, you can sit there and do math. I'm just going to copy what I wrote down, didn't you? You are such a turd. What up? No! 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 You're just copying me?
I did.
Thank you. Okay. Once you have your total, once you have it, now you got to add it all up. Add it all up. You're not going to know how to do it.
We did this in stats. I know.
You've done it before? Sorry.
Yeah, we didn't. It helped me so much with I failed of the exam.
Okay.
Yeah.
So your end total comes to 5,526.4. Then what you're going to do is you are going to find the actual standard deviation by finding the square root. Equals, and this is where you get your final answer.
Wait, what's the 10 on the outside?
Yeah.
What's the 10 on the outside?
You have to divide it by 10. Because there's 10 of them, 10 numbers.
Got it.
There's
Divided by 10.
Yeah, you gotta do what's in the house first, man. Isn't that your PEMDAS or whatever? Look at this knowledge coming out. Whatever. You knew what I meant, man. You want me to tell you about, like, the Gupta? I got you. I taught the hairpins today like a boss, man. I got the Aryans on lock. You want to know about the Vedas? I got you.
Teaching modeling, not
I am, but I gotta teach basic because I have to have the complexity.
Okay, there's some class now.
There it is. Your standard deviation. Anyone find it? 23.5.
I didn't get that. I didn't get that either. I got 3.16. What?
I got 23.
There's a point.
Square root and then square root.
Yeah, square root.
and then divide, and then that answer, and then divide by 10. You'll get 23.
I got 7.4.
Yeah, you get 23.
I got 7.4.
Your tone of surprise that my math works out hurts my feelings.
Taylor and
3.
I both got 7.4.
2. Please listen. Now, tomorrow on your test, you do not need to do this all out, but 4 years ago on the AP exam, they had kids do this. How dirty is that? Because you're not allowed to have a calculator on your AP Psych exam. They haven't done it since, but they did ask people to do standard deviation on their exam.
When you divide 5,500.
You divide it by 10? You do the house? Yes, you divide 5,500.
Wait, whoa.
It's in the house, man.
No, that's now it
It's
is.
in the house.
That was not in the house.
It's in the house.
Unclear.
3, 2, 1. So, ladies and gentlemen, I just want you to simply know how to find it if you absolutely had to. Hence why I just covered my basis. However, I will tell you there are 2 questions on standard deviation on your test tomorrow. So if you have a huge varying amount of numbers, so if it went from 160 to 37, would it be a wider average or smaller average? Wider, because the more data you have, the bigger the numbers are. It makes more sense. No, you won't have to do it. You'll just have to find mean, median, and mode. That's the only one that you actually have to do some math for. The standard deviation ones, you just have to be able to kind of process that information, and that information is coming from like here, looking at this chart. But I want you to know how to find standard deviation if you needed to find it, if you had to. And I just want to feel like I covered my basis in case it does come up. Kelly.
Wait, so with the, like, after adding all of the squares, the square deviations up, do we do the square root of that number divided by?
You divide it by 10 first, and then you square root it. And that gives you 23.5. Yeah. Okay, so you are not doing this on your test tomorrow. You're not finding the standard deviation. That would be so crappy. That's just like a lot of work for like one stupid answer. And you're not going to do that. But I do want you to know how to do it. You will be finding the mean, median, mode. You will have to do some math. Pretty simple math, but you will have to do some math. You're more than welcome to have a calculator. The biggest thing that you understand for tomorrow is your standard deviations. 1 standard deviation below to 1 standard deviation. You do need to know these numbers. Not necessarily for tomorrow, but for your AP exam, they're definitely on there. This is how your AP exams are also scored. They only allow a certain amount of 5s. They only allow a certain amount of 4s, and then 3s, and then 2s, and 1s. That's how they do it. The same thing with your SAT. They only allow a certain amount of such high scores, and then they take them down. It's all based on the bell curve, which is exactly what that is. Okay? So, is everyone okay? So, the only math you have to do tomorrow is finding your mean, median, and mode. That's it. Okay? But you will have to process the information from standard deviation. Everyone okay? All right, let's go and look at our focus and our study guide, please. Let's finish that stuff. Okay. Here we go. Who can raise their hand and tell me where we left off? Is anyone? No idea? It's a mystery. We did control group? We understand? Okay. Perfect. So we understand that control group is there strictly for comparison. Okay, what do they get in the experiment? So if we're doing like a drug experiment on weight loss, who can raise their hand and tell me what they get in this experiment? Sydney. The placebo or the sugar pill in order to convince them. What is it called in experiments? And this is on your test tomorrow, by the way, so it is worth your time. What do we call it in experiments when we lie to participants? There's a fancy word for it. Kaylee. No, but that deals with this. What is it called when we lie to participants overall? It starts with a D. Deception is correct. Yes, deception. If you don't know that term, I would definitely write it down somewhere because you will see it on tomorrow's test. I just looked at it. It's right over there. Deception. Deception is included in every experiment. Now, some experiments require deeper levels of deception. Some experiments have less. Like, what's your favorite ice cream? And, like, let's figure out which one, like, blind taste test on favorite ice cream. There's not a lot of deception in that. Can we agree? However, in other ones there are, so make sure you do know that. Okay, ethics. Now, it is important for you to know that as psychologists, we can't do whatever the hell we want. We cannot torture people. Is it on your focus, I think?
The 6 guidelines of ethical research.
6 guidelines. This is where I'm going to start filling in here in a second. Okay? As in ethics, you can't just do whatever you want. You cannot lie and treat people any way you want to. There's a specific code. I'm going to teach you 5 experiments this year that are classic psychology experiments that have stood the test of time. However, it's illegal for you to replicate. It's illegal for anyone to replicate these experiments and test them for themselves because of the psychological damage that was inflicted by it. I mean, one, for God's sakes, people were getting sodomized and peed on and pooped on, and things went wild. Yeah. On the other side, we traumatize a child and he will eventually kill himself. So it makes sense why you won't be able to replicate that one. So there are ethics. You can only lie to people so much and manipulate people so much. So here's your guidelines, by the way. The first one is the rights and well-being of participant must be weighed against the study's value. Are we going to torture people in order to figure out what their favorite ice cream flavor is? No, we're not, okay? We're not going to do that because that's not of value to society. What do you got, Kelly? Okay, do you, girl? I'm teaching. I'm recording it, though. I don't know. If you're leaving, leave. If you're not, stay. It's up to you. Okay, participants must be allowed to make informed decisions about participation. Now, I'll tell you, one of the most famous psychologists is Dr. Zimbardo. He's very famous. I have a bunch of clips with him in it because he's like a rock star. But he's the guy who had the experiment where people are getting sodomized and peeing and pooping on each other. Like, shit got wild. He almost got disbarred and thrown in jail because of his experiment and how it psychologically affected people to this day. And so one of the reasons, the biggest rule he broke, besides obviously sodomizing and, you know, peeing and pooping on each other, is he didn't let people leave and be informed about what was happening. Deception must be justified. You can't just lie to people to lie to people. You can't just do a test on how do people behave if they feel like they're going to die in a fire. Bye, sweetie. I think we all understand how we'd all react if we thought we were going to die in a fire, which is a terrible way to go out, apparently. Could you imagine? I'm sorry, what? No. Is that factual? Damn. Your eyeballs explode if you get burned to death.
Say, how do you know?
I don't think we need to because I think we're visually all uncomfortable. And I don't think we need it to be burned. But we're not going to scare people just to scare people. Yeah, a participant must be able to withdraw at any time. You cannot say, oh my God, but we've been doing this, you can't leave. They have to be able to leave. It is a huge component of it. Zimbardo got busted on this one. This is one of the flagrant ones he got in trouble for. Participants must be protected from risks or told explicitly of risks. Like, for instance, we're going to see one with Baby Albert. Baby Albert's mother was never told what was going to happen, and they never told him of the psychological consequences of scaring your child and train your child to be afraid of faces. Human faces. They conditioned a baby to be afraid of human faces. That's awful. That's a terrible life, man.
Well, if they can condition them to be like great faces.
Think about it. You can psychologically kind of work your way down. Like, my husband's afraid of snakes, like terrified. And so, like, he obviously knows we live in a 7-story apartment building. There's probably not snakes. If it is a snake, that snake really wanted to be there. You know what I mean? So, like, he can logically think that if he looks under the bed, there's probably not a snake there. But it doesn't mean he doesn't think, oh my God, there could be a snake there. because that's who he is. So brave.
Just who he is.
He's just so brave.
So
Aren't there 7 of these in the book?
Yeah. But,
Which,
and the other one,
It
I
is,
know, I
yeah.
clicked it too far, people. I think the final one in the book is like, don't do harm or something. All right, perfect. Let's go back through and kind of fill in some things that I did not fill out for you, because the goal, of course, is for me every single week to finish as much as possible. Does that sound okay with you?
Yep.
Okay, so if you look on your study guide, you have a thing called single blind and double blind. Okay, so by the way, this is on your focus, by the way. This is the last question on your focus. So if I was you, I would take a picture of it if you haven't written it down yet.
Is this the box in our study guide too?
Yeah, it is. There's a couple questions on it for tomorrow's test. So if I was you, I would just take a picture of it so you don't have to like look at the book and do it. What do you got, Alexis?
I wrote it on the paper, but I just stapled it. I wrote it on a different sheet. I mean, if I have to rewrite it,
No, you can do that. But why wouldn't you just write it on your focus or your study guide?
right.
Okay, do you, girl. Whatever it takes. As long as it's there, that's all that matters. Okay. So it's on the back of your focus. Okay, so, all right. What do you need from your focus or your study guide? Let's fill in a bunch of stuff so you have less stuff to do tonight. Margot,
On number 5 on the study guide.
what does it say?
It says using the information below, but there's no information.
Oh, you can draw a smiley face.
Like over that whole question?
Yes. Put a smiley face. It's done. You're welcome.
Thanks. Oh.
Does that work, Margo?
Yes, thank you.
Ms. Bennett. Oh, perfect. Thank you very much. Okay. What is for? I just don't know what it is.
Explain the purpose.
Whoa! I'm trying to help you, and I got people talking, and I can't even hear Caroline, who's talking to me while I'm trying to fill in answers for you. Caroline, what is it?
Explain the purpose of descriptive and inferential statistics.
Okay, first of all, what is descriptive statistics? I taught you them today. Who can raise your hand and tell me what descriptive statistics are? We have one person in the whole class who knows what descriptive statistics, and I taught you them today.
You can answer the question.
What is it? Margot?
Can I just answer it?
No, you're not just going to read your answer. What is descriptive statistics?
Statistics that have research. I can answer
Descriptive
the question.
statistics. What are they? There are 3 components to it. What is it, Hayden?
They're numbers that describe the set of
Yeah, what would be the 3 examples that I taught you today, Hayden?
median and the
Mean, median, mode, ladies and gentlemen. Descriptive statistics take down large pieces of information and breaks it down and simplifies it. Descriptive statistics take large amounts of information and simplify it and make it manageable. If you know, if I give you all 60 of my kids' scores and say, when you're like, Miss Bennett, how are kids doing today on the test? Which is what I'm going to hear all day tomorrow, because AP World's taking their first test tomorrow. They're so stressed out. I don't know if you saw them coming out of my classroom. They're like, it was so stressed. Manageable bits of information. They're going to be like all day, Miss Bennett, how are people doing on your test? How are people doing on a test? And if I show them what all the test scores are, is that going to help them? What do they really want? Average. And that's why descriptive statistics simplify large chunks of information, because I have 132 AP World kids. Instead of having 132 test scores on the board, they just want to know the average because it makes it easier for them to process. That's descriptive statistics. It makes large amounts of data simpler and more applicable to use. Makes sense. Okay, and what's the second part, Carolyn?
Inferential.
What is inferential statistics? Hayden?
it tells you whether a phenomenon is significant or not.
There you go. Inferential statistics tells you if there is something occurring or not occurring. Okay? Inferential statistics tell you if something is occurring or not occurring within the data. If all of the data is moving upward on my weekly test, what is that telling you? Is something happening? Yes, if my average score goes up every single week, are my kids getting smarter? Yes. Okay? It allows us to look at trends in data to figure out where information is heading. So while we're collecting data for experiments, we want to know where is the data going instead of just being completely surprised. That's inferential statistics. All right, perfect. All right, what else we got? Kaylee?
Random sample.
Random sample is when you, in order to eliminate bias, you pick people out of a hat to put them in a group. Or you allow a computer to pick them in order to eliminate bias. You don't put people specifically together. All right, what else we got? What do you got, Madison?
Application of observer bias.
Observer bias. Miss Bennett thinks high schoolers are dumb. I don't know. Well, what is, like, you think old people don't, like, you think old people are boring, right? I would assume. I don't know.
Can't use it.
Old people can't use technology. That's a bomb one. So you're watching, you see a bunch of people, like old people in a room, tech room, and you're like, none of these people know how to use this. There you go.
Yeah.
What do you got?
Describe how research design can provide for cause and effect on experimental control and produce.
All right, hold on. Give me one part of the question first.
Describe how research design can provide for cause and effect.
Okay, here we go. I'm on the front. I'm question what, number 2? 3? Question number 2 on the front of your focus, by the way, if you would like to join us. It says, one more time, I'm sorry, please don't hate me.
Describe how research design can provide for cause and effect.
Cause and effect. So, research design. It has to, with a clear independent variable, dependent variable, and operational definition, cause and effect are easily apparent. Independent variable, dependent variable, operational definition, cause and effect is clearly listed. You can see the connection or causation. Are you okay, Annalise? Independent variable, dependent variable, and operational definition, you can see that there's a cause and effect relationship, or there's not a cause-effect relationship. Operational definition. All right, what's the next part?
And how experimental control reduce alternative explanation.
Okay, by limiting external components, we are able to focus as closely as we can on the impact of the independent variable on the dependent variable.
Read that last part.
By limiting the circumstances, we are able to focus on the impact of the independent variable on the dependent variable. Okay. Tomorrow you do have a test, 25 questions, all multiple choice. You shouldn't be as stressed for this test as you were the last test. Can we agree?
Yeah.
Now you know what the test questions are look like. You're going to see some are straight up definitions. Can we agree? You are going to see that some of them tomorrow are straight up applications. All right, guys. Hopefully you shouldn't have a ton of homework tonight. Is that correct? Okay, I'm not talking about other people's class. I'm talking about me.
Yeah.
Yeah.
Okay.
I mean, I'm gonna use 40 if I stop.
You don't have to do that now. You're just reading the actual content, yeah. I mean, looking at those test questions maybe would be a good idea.